All right, so welcome back, guys. So we're still exploring the idea of the less than or greater than symbol. And so, as I was asking before, Ms. Waysome, to explain your conclusion, why you say that this less than or equal less than statement would be true. So give me a reason, and then we move on from there. Ms. Waysome?
Yes, sir.
So give me a reason, huh?
Sir, my reason being, because we know to the right, we always have greater values, and to the left we have lesser values, sir. And then the 4 would have fallen to the further left than the 2, sir.
What are you referring to the right and to the left, miss?
Sir, the right with positive numbers, sir. So when we're going to the right,
you're referring to numbers on the number line.
Yes, sir.
Based on their position in relation to 0.
Yes, sir. Right. Yes, sir.
Right at 0, they are positive.
Yeah.
Of 0, they are general negative. So the more.
Yes, sir. But sir,
right
this. I'm sorry, sir.
Is the more to the right you are, the greater the values.
Yes, sir. That is what I'm saying.
You are, the less the value. So on the number line, -4 would fall more or less than -2. Even though it is numerically a bigger value, negatively, it is a small value. All right?
Yes, sir.
That is something to bear in mind. Now, with all of that said, that leads us to something very important about inequality that we have to pay attention to. So when we are solving the equation, oftentimes we may divide both sides of the equation when we are solving. Now we do the same thing with inequality too. We may divide both sides of the equation in inequalities, or should I say both sides of the inequation. Now, when we're dividing both sides of the inequality by a positive number, we really don't have a problem. Or not only dividing, if we are dividing or multiplying, so it will go both ways. So if we are multiplying both sides by negative, or we are dividing both sides by negative, we have to pay attention to the symbol. If we're dividing both sides by a positive, by the same value, there's no problem with the sign. Because we see that if you divide 4 by 2, you will get 2 on the left side. Now, on the right side, if you divide 2 by 2, you will get 1. And so the inequality still remains true. It still remains that it still remains that 2 is greater than 1. That still remains true. But if we should, instead of dividing by positive, if we should now divide by negative, it will change the whole situation. So we divide both sides by -2. Then if we divide the left side by -2, we're going to get 4 divided by -2. We're going to get -2. And if we divide the right side by -2, we get 2 divided by -2. We're going to get -1. Now, if the inequality symbol remains the same, we now have to see whether or not that statement is really true. So the question is -2 greater than -1? Is that true?
No, sir.
No. And because if we divide both sides by a negative, it cannot remain true by having the inequality symbol staying the same way. But if we reverse that inequality symbol to the opposite, now the statement will be true. And so for that reason, when we are dividing by a negative, we generally reverse the inequality symbol so that our inequality becomes true. Is that clear, guys? So that's something very important that you have to remember. If you're multiplying both sides by a negative, you have to reverse your inequality symbol, right? So if the symbol is pointed this way, when you divide by a negative, you reverse it to the opposite way. Is that clear to everyone? Raise your hand if you understand that. Very important thing to note. All right, I see Ms. Waysome understands it quite well. Who else is understanding what I'm saying? All right, Mr. Lamar, Mr. Artie, Mr. Green. All right. So bear that in mind each time you're working. You can lower your hand now, Mr. Lamar. Each time you're working with your inequality symbols, if you're dividing or multiplying both sides by negative, you reverse the inequality symbol. All right, so here we can look at this inequality situation. So if we are solving this, it's a less than or equal to symbol. So we, as I said, we treat it in the same way as equation. So sometimes some teacher will put an equal sign here to work it out. And then now at the end, they put in back the inequality symbol. But you are mature people. I don't think we need to do that for you. So we treat it same way as the equation. Bring all the x's to one side. So we want to bring them to one side and group them. So we bring this positive 5 to the left. So we'll get 3x minus 5x. Now, I want you to also note that if you're adding and subtracting to both sides of the inequality, that does not affect the inequality symbol. Only when you're multiplying and dividing, you have to reverse the symbol. All right, guys? So if you're adding and subtracting to both sides, you don't change or you don't reverse inequality symbol. It remains the same. All right, so here now, to the left side, we see that numerically, we have a negative 5, and then we have a positive 3x, negative 5x, positive 3x. But that when we do the calculation, you take away 3 from 5x, you keep the sign of the larger number. So this becomes negative 2x. All right, so that's on the left side of the inequality. Now on the right side, you're going to add 6 plus 2 and you will get 8. Now, in order to get x by itself, we have to divide both sides by negative 2. And so what should we do in this case now when we do our calculation? So this will cancel. So on the left side, we leave with x. And negative 2 into positive 8, that will give you negative 4. Now, here is where we need to pay attention now. How do we position our inequality symbol between these two? Does the symbol remain the same?
No, sir.
Do we keep the same?
No, sir.
Or do we reverse the symbol?
Reverse the symbol, sir.
All right. So I hope you guys remember to do that. Once you're dividing by a negative, the symbol now has to turn around. So it was pointing to the left. Now we have to point it to the right. All right. And so this now becomes true. All right, guys. All right. So with that said, let us move on quickly. So it means then, solving this, dividing both sides by 2, we reverse the inequality symbol. All right, here now is another question. All right, now let me give you a chance. Just try to solve this question for me, guys. Solve this question, and then when you're finished, you raise your hand, and then we share the answer that we arrive at. Anybody finish as yet? All right, let's say some. What you get for your answer? What you get for your answer, Mr. Sam?
-5, sir.
Okay. Well, but it's just -5. You must have some symbol in there. What you get for your answer, Miss Green?
Sir, I got -1.
Okay, Mr. Sam, I can lower your hand. All right, so let us just go through it quickly. So in this case, you may want to remove the bracket, multiply out what is in the bracket by what is outside. So you get 3x plus 12 minus 5x plus 5. You have to remember now, if you are multiplying inside the bracket, negative times negative give you a positive. It can become confusing to remember all of these rules when you're learning something new. But remember now, you have to say -5 times -1 give you a +5. All right, so here now we group all the x's together and simplify them so we get this. And now we would bring the 17 to the right side, subtract it from 19, we get this. All right, now we need to divide both sides by -2. And so if we divide both sides by -2, we have to flip around the inequality symbol. So your answer should be x is greater than or equal to -1. All right, so now, so what would be the values for x? Now, when we're dealing with inequality, our values for x is not just one value. Now, when you think about what the statement is saying, x is a value greater than -1 or equal to -1. Can you think of all those values that are greater than -1 and equal to -1? So what it means, the actual value or values for x will be a range of values, not one value, but a range of values. So x is really, the values for x would be a set of values. So the actual values, when you have x is greater than or equal to -1, the actual values would be a set of values or a range of values. But if it is equal to -1, it means -1 is included in the set. And the rest of values should be greater than -1. So what are the other values greater than -1? So you would have 0. You would have 1. You would have 2. You would have 3. And then you could go on and on and on to infinity. And so these are the set of values which satisfy the solution for x. So there's no one value here which is a solution for x. There's a number of values that will satisfy the solution. Is that clear, guys? Raise your hand if you understand. If you're not clear, let me know. Ms. Green, understand?
Yes, sir.
Okay. All right, so I'm taking that those persons who did not raise their hand, one out of two things. Either you didn't understand or you do, but you just don't want to raise your hand.
Sir, I didn't understand.
Huh?
Sir, I didn't understand.
Okay, you didn't understand. So we are saying that, remember now, if it was an equation and we say x is equal to -1, then it is only one value that would satisfy x, -1, because it would have to be equal. The left side would be the same as the right side. But in an inequality, when we say the x value is greater than -1, so we are saying the value for x is a value greater than -1, or it's a value equal to -1. So now you have to consider all the values greater than -1 to be x, and all the values including -1 because they have the equal sign to it. Is that clear now, Mr. Lamar?
Yes, sir.
Okay, good. All right, so with that said now, these are some other questions that I would love for you to indulge yourself in. Let me see if we have a little time for, so we have about 9 minutes remaining. So I'm going to just ask that you, just going to give you 2 questions here to do. All right. So of course, I'm going to choose question 8. So you're going to do question 8 for me. And I'm going to choose I'll choose question 11. So I want you to do question 8 and 11 for me, guys. Raise your hand when you finish with these.
Repeat.
You have to do the 2 questions that I've circled here now. All right, and the rest of them you're going to do for homework. So I circle question 8, so I want you to do question 8 now. I circle question 11, and so you should do those 2 now. Question 8 and 11 should be done now, and the remainder, you can do those as homework. All right?
Yes, sir.
All right, so did anyone finish question 8?
Yes, sir.
Okay, what did you get for question 8, Ms. Raysom?
Sir, I got x equal or greater than 2, 5 and 4 over 5. I got a mixed fraction.
All right. So let me go through it and then now verify your answer. Anybody else have another answer? All right, so here we have 2x in the bracket here plus 3. Close bracket equal less than or equal to 14. All right, so first thing you want to do is to remove your brackets, multiply them out by what is outside. So 3 times x give you 3x. And 3 times -1 give you -3. And -4 times 2x give you -8x. And -4 times +3 give you -12. And so that's less than or equal to 14. Now we can keep the x's on the left side, bring all the numbers on the right. So we want to bring across -3 and bring across -12. So this will leave us on the left side with 3x minus 8x is equal to 14. Sorry, let's not use equal to, but less than or equal to 14 plus 3 plus 12. All right, so on the left side, we subtract 3 from 8. That leaves us with -5x the right side, we add what we have. So that would give us 26 plus 3, give us 29. And divide both sides by -5. So we'll get x. What was your answer, Ms. Wilson? Ms. Wilson?
Yes, sir. I was saying 5 and 4 over 5.
All right. So that would be -29 over 5. All right. Now, if you want to convert it to a mix, no problem. So we say 5 and 4 over 9.
4 over 5, sir.
4 over 5, brother. All right. Yeah. All right. So that would be correct. And remember, it's less than or equal to. Don't confuse the sign as I'm doing here. All right. So that would be for question 8. So let us now look at question 11. All right, so for question 11, remember now we can simply treat this in the same way as the equation. So we can use the same principle of cross multiplying with the denominators. All right. So we can cross multiply with the denominator. So what is in the denominator on the right side, we use it to multiply the numerator. Sorry. What is in the denominator on the right side, we use it to multiply the numerator on the left side. And what is in the denominator on the left side, we use it to multiply the numerator on the right. So we would say 3 times 4 on the left give you 12. And so 12 is less than or equal to 2t. And so if we divide both sides by 2, then we would have 6 on the left side less than t. And if we want to make t, bring t on the left side, we flip around this. But while we are flipping around this, we have to flip around the sign too as well. So now we can say t, we flip around the sign once we are doing this flipping around and put this 6 on this side. All right. Any question, guys? And that would be it. So pretty much you could try the others for homework and for practice, because they need to practice. All right, so with all of that said, we're going to stop here for today, and we'll continue with this topic next class. All right.